Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. A particular difficulty that students exhibit when utilizing counting techniques is recognizing when to use a permutation or a combination. In essence, we know a permutation is utilized when the order or arrangement of the elements matters, while for a combination, the order of the elements is irrelevant. I challenge my students with this probability problem. In a game of 5-card stud poker, you are dealt 5 cards. Determine the probability you are dealt 2 pair, which is 2 cards of one rank, 2 cards of a different rank, and a remaining card a third rank. If you'd like to try this problem on your own, you should pause this video now. Now, students do recognize that the number of ways in which the cards are dealt is a combination. So being dealt 5 cards from a deck of 52 playing cards is 52 choose 5, which is 2,598,960 different ways of being dealt a 5-card hand. So far so good. However, it is at this point that students struggle when totaling up the 2 pair. Instinctively, they understand that there are 4 choose 2 ways to select one of the pairs and 4 choose 2 ways to select the other pair. Realizing that there are 13 ranks in a deck of playing cards, they multiply the first pair by 13, and since the second pair must be a different rank than the first, they multiply the second pair by 12. They then understand that the remaining card must be a different rank than those of the pairs, leaving 44 cards left to choose from. Multiplying all of this and dividing by the number of ways a 5-card hand can be dealt results in a probability of approximately 9.51%. However, this is incorrect. I emphasize to students that it is the rank of the cards that makes the dealt hand unique. That is where they should focus their thinking. Trying again, they realize that there are 13 choose 2 ranks to choose from for the 2 pairs. Now from these ranks, they determine the number of ways to select each pair, finally leaving 44 cards left for the last card. Multiplying the results and dividing by the number of possible 5-card hands has a probability of approximately 4.75%. However, students are confused as to why one method results in a different output than the other, and how are they supposed to tell the difference to keep from making the mistake again? Now, they rightfully know that the order in which cards are dealt is irrelevant. They've demonstrated this by utilizing a combination when totaling the number of possible 5-card hands. I explained to students that in their first technique, they purposely assigned 13 to one of the pairs and 12 to the other. This deliberate arrangement treats the 2-pair ranks as ordered, thus turning this process into a permutation. For the most part, permutations inherently result in more outcomes than combinations, and this example shows it double counts the results of the 2 pairs, resulting in a probability that is twice as large as the other. Now, it is difficult for students to formulate the logic behind the application of the counting techniques. This is where guiding them to keep the problem in context helps. Focusing on the ranks lends clarity on how to proceed. So I asked students to try a similar problem, except this time they are to determine the probability of being dealt 1 pair, which is 2 cards of one rank, and the remaining cards are all different ranks. Again, if you'd like to try this problem on your own, you should pause this video now. Focusing on the ranks, we know that there are 13 different ranks for the pair and 12 choose 3 different ranks for the remaining cards. So far, so good. From the pair, we now have 4 choose 2 different ways to select it, and from the remaining cards, there are 4 ways to select each one. There is no assignment or arrangement suggested, so it seems logical that the process is correct. resulting in approximately 42.26% probability of being dealt a pair. Instinctively, being dealt a pair in a poker hand is more likely than being dealt two pairs, so the probability makes sense. To help continue expanding this site, please don't forget to subscribe and like. Thanks for watching.